3D.
Yeah.
So it looks like that.
Yeah.
And then it has a little,
from
below, a little
yep.
cylindrical piece that fits on. There we go. We'll draw it upside down this way. There we go. Now I can see it.
How high does it go up?
Oh, just a couple inches.
Okay.
But then it has a certain fastening pattern here.
Got it.
Which Simpson has engineered that this will stay on the column and this will keep the wood from literally doing that.
Okay.
The other trick here would be I see, you know, for all this work here, it's probably worth teeing the gas line up and going over the beam.
Okay.
You know?
Yep.
Like if this is as important as it looks, you know, and just because as you're observing, when you get two different pieces of wood, these little toenails aren't going to cut it.
Yeah.
You know, those aren't enough to combine it. If we were trying to make a composite beam, then, you know, say if there was a really good reason for having two beams like this with a column cap, then you want to do the thing where you get the plywood on either side. That's connecting them together.
But would I be accurate in saying those are different ways of going about it, and this is something that I could always adjust after the fact?
What are different ways? What I'm describing?
Yes.
No, this is done incorrectly.
Okay.
This is done in, well, it's failing.
Yeah.
So it's not like if you had screwed it better, it wouldn't have failed.
Oh, but that's what I was.
You know.
Yep.
This should be a column cap. This should be one piece of wood.
So one piece of wood would have made a difference? If I had two pieces of wood that were kind of screwed together?
If you had two pieces, if you had one piece of wood here with a column cap, there's no reason it should have shifted.
Okay.
It actually, what you're seeing here, the shift is what it's telling you is that the house is pushing on it. Which is good. Which means that
it's doing its job.
Well,
it's supposed to be.
Because it's not collapsing, you know. So if it's a single piece of wood with a column cap, the single piece of wood isn't going to buckle.
Can I get a single piece of wood that big?
Oh yeah. What's your height on that? That's a 4x6. Yep. So you might be doing when I say single piece of wood, I mean you would probably get two 2x12s next to each other, and then those get fastened together. Rather, what he did was he's got a 4x6 and a 4x4 right there. You just don't do that. You know, you would use two.
Okay, so not one piece of wood, but two like pieces of wood.
Yeah, and then those are anchored, fastened together, because it's way easier to hold something together this way than like the toenailing. So, I don't know anything about the person that did this. Seeing this, I would be doubtful they would come back and all of a sudden do it right the second time. Because then you would have to explain it to them, and it's like once you start explaining to the contractor how to do their job, you've already lost.
Who would you recommend that would do something like this?
What's the problem? I mean, if I was doing this in my own place, I've got a couple guys I've worked with, you know, but I'd probably sketch it up for them, you know. The problem is when you're asking a contractor to come up with a structural solution and do the work, it's
conflict of interest.
So I was like, I got one of these in my truck.
Which is
and even actually cutting that top piece is doing nothing now
because it's cut,
other than just performing as blocking. They actually notched the top of this this one here, so this one's really only performing as 5 inches right there. So I wish I had a small contractor that did good work, that didn't charge too much, that was really trustworthy. I've got someone in each of those categories, you know. But,
How much would it cost to sketch something up like this?
If we're doing other work in here, you know, and then it's not like it's a separate startup. The trick with this, this is just one piece of a bigger puzzle.
Right.
You know, because when we run, so we'll do our own structural as long as it's quote normal. When we find like weird stuff, we have an engineer that I work with on my own stuff, as well as our commercial clients.
Yeah.
Like you did a foundation detail similar to what you had done over there for me.
Yeah.
I would just be hesitant.
Yeah.
Because, you know, I could totally look at this and say, figure out how much load you have coming over here.
Yeah.
Because it starts.
Yeah.
Where does it start? Let me just talk through this with
you.
Go
ahead. No,
sure. So you can kind of see how me or anyone else should approach it. So the first question is, why did we pick this location?
Okay.
You didn't?
No, don't know. I think he thought, well, no, I can't tell you.
So, assumedly, this was a low point in a hallway or bedroom or underneath the wall.
You know, I think
there's a bedroom back there.
I think this is the hall.
Yeah.
And I think he had built up some reinforced the wall on this line on the first floor and on the second floor.
Yeah.
And I think he said you just need more support on the bottom.
Okay.
Because there's, you know.
So that'd be the first thing. Is this actually the right
spot
location?
Okay.
Yeah. So if you had, say there was a wall above this.
Yeah.
Walls are heavy.
Yeah.
If the floor is sloping to the wall on both sides.
I think that's what was happening.
Like, that's pretty logical.
Yeah.
So let's assume that's the issue that we're trying to remedy here. We said, okay, we got that. Now, what load is on here? So you have some dead load of the wall above.
Yeah.
So what we would do is actually just calculate, you know, so it's about 10 pounds per foot, vertical foot of wall.
Yep.
You know, so if there's walls stacked on 3 floors, you know, then it is 300 pounds per foot. Then the question is, what else is loading on there? From the second floor, if there's a wall and you've got a joist and the wall touches the top of the joist, it's going to transfer load down.
Yep.
You know, even if the joist spans from here to there and there is a wall over there, if you catch a joist with a wall, it'll transfer the load.
Yeah.
So it could have been the way, and there's ways to build so like if you had actually.
Yeah.
See, it's something like this. We had structure, structure, intermediate wall.
Yep.
You know, you can actually use a deflection piece right there, just so that you know it's connected with the drywall.
Yeah, but not.
But it's not transferring load. So maybe this is one of the reasons why the house is kind of wonky. Is because, as you can see, the structure is kind of all over the place.
Oh yeah.
Changes directions a lot.
Yeah.
And you know, if builders were used to building in like 20-foot increments,
right?
Now we're like 35.
Yeah.
They start doing a few things, breaking a couple of the rules, which a lot of that wasn't as engineered. It was more just kind of standards.
Yeah.
You know, so that could be why. So this could be actually holding your second and your third floor as well. So it could be transferring load there, which would make sense that this would start to give. From what we see here, everything I talked about here is possibly also happening upstairs as well too. And so, all right, so what's on here? So this joist, half of this joist is going this way, half the joist is going this way.
Yep.
But now when we look at this one here, it's like half of this is going that way, half of this is going this way. So before these were added, you actually probably had not just half the load going to this, or actually probably a good portion of the whole thing once you start to draw your little diagrams.
Yeah.
So actually calculating what you're drawing the beam correctly here, that's like super easy. I can sketch that right now.
Yeah.
I just figuring out what we're actually doing. That's the harder part, you know, because then you've got to say, okay, what's happening on the floors above? Is the wall that's above this actually transferring that load there?
Right.
Or is a lot of the load getting transferred down to this one over here? And then there's all that, but then it's like you can kind of get lost in the weeds.
Yeah.
It's like, what are you actually trying to do? So,
I mean, my obviously the person who did this, I called back to say something's wrong. Can you fix it? I'm assuming he's going to come back, take this off, straighten it out, put some screws in. That's a Band-Aid.
Yeah.
I'm wondering if I should do that and just, I mean, that will last me a year, perhaps.
Yeah. Yeah. If he's going to come back and fix it, you might say that you want, 2x12, two 2x12s.
Okay.
Rather than, I mean, now you're being prescriptive, but, you want a column cap, you want two 2x12s. This approach is obviously not working.
And if I'm doing that, does it make sense to change my...
I'd probably pop your gas line over it.
Okay.
Yeah. If you get a plumber, that will do that for him without taking you for a huge ride.
Okay. And that would be a reasonable Band-Aid, you think?
It's less likely to fail like this.
When we start to dig into the third floor, would it warrant getting an engineer down here?
Yeah, so especially if we're moving walls around and going to kind of more open plan, we usually look at where we're dropping our load onto.
Yep.
Usually the third floor is not too bad because the roof usually goes to the exterior walls. It doesn't usually load in the middle of the building.
Yep.
But it's the sort of thing, if you're doing that amount of work, then you're going to have people that are here that are good at framing that kind of do more substantial work.
But if I'm on the third floor, would the framing have to happen below it, or?
Well, it's likely that we probably wouldn't be putting roof load onto the floor.
Okay.
So on when we do third floors, sometimes you're moving a wall around, but it's not like you're taking roof load and dropping that down below. Because on the third floor, that load is still going in the same path it would have been before.
Okay.
And then the roof is still following the same path.
Okay.
It would have been before. But if you're doing the work on the third floor, you probably have contractors here that are better at sort of rough framing and those sort of things. And then if you're doing a solution down here, looping those two pieces in would probably make sense.
Let me make sure I follow you. You makes sense because I've got a contractor here.
Correct.
Okay.
Yeah.
But would I need an engineer to kind of tell us what to do?
Yeah, for something like this, we'd probably want to work with our guy Jeremy.
Okay.
And yeah, it's a thing. It's a little confusing now. What we or he would end up doing is just documenting where the joists are, where the beams are, where the columns are, and like I said, it's hard to do that just kind of walking around.
Yeah.
But it's funny, the moment you do a sketch, you're like, oh, this piece isn't supported, or it's like you lay the floor plan over it, and it's like you see this with a floor plan above laid over it. And it's like, well, that's obvious that the wall in between everything is at midspan or something like that.
Okay.
So
Let's